Hello everyone. I would like to go over what we did with classes on Monday and go over a couple new topics in the subsequent videos, and then we'll reconvene on Friday and keep going. But I wanted you to have a video with everything that we did in class just so you can go through it at your own pace. Okay, so what we talked about were classes. And I want to remember the motivation here first. If we go back to the holidays lab, we saw that there was a way to couple different pieces of information together about the same thing. So for a holiday, we had the names of the holiday, the month number, the day of the month, and then the year. And so we could use parallel arrays to pull out different pieces of information for the same holiday. But this information became decoupled. So if I wanted to add a holiday, I would have to find the right place in all four of these arrays to add it. And so it would be better if we could somehow encapsulate, that's the key word, encapsulate this information, to put this information inside of a capsule so that we could change it all in one place for a single holiday. And that's really the motivation behind classes. So anytime that we have something a little bit undesirable in our syntax and code that leads to something that's messy, or that leads us to having to type the same thing over and over again with minor variations, so in this case having to index 4 different arrays. Whenever we have these pain points in coding, we try to see if we can come up with more general paradigms to help to write better code. All right, so let's do an example of a class like we had talked about. I'm just going to go and jump straight into it. I'm going to save the holiday example because I want us to try that together. But I'll do a class which encapsulates what it means to be a person. And so what I was saying in class before was that, a person has a name, they have an age, and let's say for now that they have a height, maybe in centimeters. So I'll put in comments units here. All right, now this little section here is what's known as instance variables. Okay, so I'll dive a little bit more into that in a moment, but for now, you can think about it as all of the pieces of information that I want to encapsulate or couple together within a single instance of this class. Okay, so you can think of the class like a designer variable type. That's the way I like to think about it. So it can store anything you want. It doesn't just have to be this primitive type, okay, it's just one number or it's just one character or whatever. You can actually say, hey, you know what? I want a type which has all these pieces of information together. And so then what I can do is create an instance of that type. Maybe I'll do myself. So what we say here is Chris is an instance of the person class. And we refer to instances of classes specifically as objects. So we refer to instances of classes as objects. So just to continue with this example here, if we had int x equals 7, well, x is an instance of the int type. And if we had char c is equal to a, then c is an instance of the char type. So what I'm trying to get you to understand here is the difference between the type, so int or char, and an instance, which is a specific variable that is storing information in the format of that type. So in the case of a class, we say that the instance is an object. And that's just the terminology we use to refer to it. Okay, so Chris is an object of type person. Person is my class designer variable type. Now, how do I then drill into this specific information here? Well, I can use the dot notation. So we can use the dot notation to set instance variables. So if I said, for example, Chris.name is equal to Chris, the string literal Chris, that would work. And then I could say Chris.age is equal to that. Or actually, I should give my actual age, which at the moment is 33. Chris.height is equal to, let's see, this is supposed to be in centimeters. I don't know. Let's pretend I'm very tall. Okay. So it's over 9,000. So let's compile this real quick. I always like to, I've certainly written more than enough code to compile and make sure I don't have any syntax problems. And so that works fine. It is complaining about converting the string literal, which this is a bit of a rabbit hole that we went down in class, but the string literal actually is data that resides in the data region of memory, which is above the heap even. And so a pointer to that region, it actually is constant in that region of memory also. What we're doing is assigning a pointer to that region of memory to this, and it doesn't like the fact that we're pretending that that pointer is not constant, that this thing can actually move around, and it doesn't. It's in this region of memory. It's always going to be in that data region of memory, the character string CHRAS. So if I wanted to get rid of this warning, I could just make this a const char. Okay, that's TLDR, okay. So, and if we tried to change anything there, we'd get a segmentation fault. Okay, whatever. The more important thing here is the dot notation. So that's cool. But what's maybe a bit annoying about that is that I have to set each one individually. So again, there's something about this that's a bit clunky. I keep having to say Chris dot the thing, Chris dot the thing, Chris dot the thing. And so there is, as we talked about, there is a more efficient way to do all of this code-wise. We have a method called the constructor that we can use. And so this is a method like any other method, but it always has the name of the class. And it has no return type. Okay, so it doesn't return anything. It's a void method, but you don't even specify a return type there. And this is a method that gets called when an object is instantiated, which is the word we use for an object when it's initialized to something. And so just to show you that something's actually going on there, maybe I'll output something. Maybe for now I'm just going to have the constructor output. We just made an object of type person. And so maybe I'll print something before this, before Chris declaration, and then I'll print something after Chris declaration. And if I recompile this and I run it, oops, person, I see that, when this line gets run, so sandwiched in between the before declaration and the after declaration, this line here actually calls the constructor because I'm initializing. I'm doing actually a default initialization, but it's calling this method here on that line. I know it doesn't look like a method call, but it is. And so then we see, okay, this method simply is just printing something right now. So that's kind of interesting, but not particularly useful yet, because we can also add parameters to this method. And so here's where I can make a better version of initializing all the instance variables. So if I want to change the variables associated to Chris, I can actually do it in the constructor if I pass them along as parameters. So what I'll do is I'll add a few parameters here. So let me just get my comments under control here. All right, so these are parameters to the method. It's like any other method. It has a place on stack frame, or it has its own stack frame. It has a place on the stack. It comes along with parameters, and you can have local variables. The difference is actually because this is in, we call this now instance method. So we have our instance variables, but then we also have instance methods. This also in addition to having access to its own local variables and parameters, it also has access to the instance variables. So I'll say every instance method has access to the instance variables. So they're within scope. So I could actually, in this example, I could set the name to be the parameter that I passed in pname. And then I could set the age to be the parameter that I passed in for the age, ph. And I could set the height to be the parameter that I passed in for the height. And okay, so now I just need to call this method somehow with those parameters. And this is going to look especially weird, but we do it in the same place. So I can call the constructor by actually adding parentheses after the declaration of the object. This is called a static instantiation of the object. So I can say, all right, let me pass along Chris. 33, I forgot how old I was for a second. And then 9001. Okay, so now I don't have to do this whole clunky thing. What I'm going to do is call this constructor method with these three parameters and then save them away. Oops, yes, make that a const chart. And so because these instance variables are within scope, if I set them in the constructor here, it will actually affect them in the object. So just to show you that, maybe what I'll do is I'll make another instance method. So say maybe void print info. And I'll say, okay, maybe I'll print out what the name is. Pname is age, years old, and is, maybe height, centimeters tall. All right, so I have another method here. This is also an instance method. What that means, again, is it can have its own parameters, it can have its own local variables, but it also has access to all of the member variables, all of the instance variables of this object, okay? So I can actually set something in the constructor, and then it will persist throughout the lifetime of this object. And so I can access it later in another instance method, okay? So every instance method has access to the instance variables. And so what I can do is after I construct Chris, I can actually call this instance method. And we also use the dot notation for this. So if I were to say chris.printinfo, and let me go ahead and compile this and run it. Oops. Whoops, it didn't like that. I meant to say the name of the instance variable, which is name. Okay, I missed one. Okay, so now when I run this, it says Chris is 33 years old and is 9001 centimeters tall. So let me just step through that again, make sure it's clear. This instantiated the object. It actually called the constructor in the process. I know this looks weird. This is a weird way to call a method. But when I do this, it's actually calling the constructor method as the object is being created. I passed along to that constructor these three variables. I then remembered those variables that were the parameters. I remembered them in the instance variables here. And then once this constructor was done, I could then call another instance method later, which could access these variables. So that's pretty interesting. And I can make as many instance variables as I want. I can make as many instance methods as I want. So you can see now a class is actually even more powerful than just storing a bunch of stuff in one capsule. I can also create methods that act on that stuff. So in this case, I had a way that I wanted to print stuff out. But I could also have a method to celebrate a birthday. So to advance an age by 1 year. And I'll have you do an exercise on that in a moment. Okay? But just one more quick thing I want to say about instance variables. I can make another object here. I could say person, oh, I don't know. Maybe I'll say Nick for our chair. He's a sage, so he's probably like 80, and he's even taller than me. Okay, so what I want to note here is that Nick's instance variables are completely separate from mine. Okay, this is why we call this is why an object is different from a class. The class is the type, but the object is the instance of that type. And so Nick's instance variables, if I want to change Nick's age, that would have nothing to do with Chris's variables. So maybe what I'll do to show you that is I'll set up Chris like this, then I'll set up Nick. And then if I say Chris.printinfo, and then I say Nick.printinfo, when I called the constructor for Chris, I set the variables like this. When I called the constructor for Nick, I set the variables like this, but then I changed my mind. But that won't affect Chris at all. Okay? So when I compile this, I will see that I get Chris is 33 years old and 9,001 centimeters tall, just like we did before. Now it says Nick is 100 years old and 1,000 centimeters tall. So notice I was able to change Nick's age from what it was initialized to be. But that doesn't affect Chris. Okay, so each one of these instance variables, each one of these objects has its own set of instance variables. And for the same reason, it doesn't really make sense for me to do something like this either. If I were to try to say, okay, let me just return the age in this method here. Well, that doesn't make sense because it says age was not declared in the scope. This method is not an instance method. It's not inside the class, right? So this doesn't belong to any particular object, so it doesn't make sense for me to look up an age. It's not within scope here. The only things that could be within scope are parameters to this method, or local variables, or global variables, but certainly not instance variables. So if I wanted a method that used an instance variable age, well, it'd have to be inside the class so that it'd know where to find these instance variables. Okay? So this takes a bit of getting used to. Oh, and of course, this shouldn't be a void method, it's returning something. So there we have it. Okay, so let me have you do an exercise there real quick, and then we'll keep going.